Okay, so I'm going to do lab number 1. It's called identification of a substance. What we're going to do is I have an unknown, it's pure substance, as pure as it can be, and I don't know what it is. I have a choice of the possible things it can be. What I'm going to do is I'm going to do 3 tests and compare my 3 tests against some knowns that have had the same 3 tests done and see if I can figure out what my unknown is. Okay, so the first test will be something called solubility. And solubility is when you check to see if 2 liquids or solids, or solid and a liquid, can dissolve. So what we're doing is creating either a homogeneous or a heterogeneous mixture. So what we're going to do is I'm going to take my unknown liquid and I'm going to add it to 3 known liquids. And if my unknown dissolves in the known, we call that soluble. If it does, and that'll be a homogeneous mixture. All right. If it doesn't dissolve, there will be a clear separation, just like oil and water, and that will be called insoluble. And that'll be a heterogeneous mixture. The third possibility is sort of a mix between the two, where it looks soluble when you mix the two, but when you shake it up, you can see that there's particles that seem to be insoluble. So we say it's slightly soluble or slightly insoluble. So we're going to do that test first. The second test I'm going to do is I'm going to be measuring the density of my unknown. And density is mass divided by volume. And so what I'm going to do is I'm going to measure the mass of a substance and its volume and determine its density by dividing the mass by the volume. Okay, the third test or experiment is to find the boiling point of the unknown. And I'll go over that when I actually do it, but every pure liquid has a unique boiling point. And I'll talk about boiling point when I get there. Okay, so what I'm going to do is I'm going to do the first 2 parts, solubility and density. And then while I'm doing that, well, we'll see how that works out. I want to do those first. I will add the boiling point as an added video, but it'll still be part of this lab. What you need to do is, as I go through this, what you need to do is record what I ask you to record. So the first thing I'm going to ask you to record is if the unknown is soluble in the particular liquid. The second thing I'm going to have you do is, I'm going to be weighing a substance. You're going to be recording its mass. I'll be getting its volume, and you'll be recording its volume. Okay. And then finally, on the third part, the boiling point, you will be recording the boiling point. Okay. So let's get started here. Okay, so what I'm going to do is concentrate over here. And what I'm going to do is I'm going to take my unknown, okay, which is right here. and it could be a possible of 5 or 6 different things. Those things are in your lab board. This could be acetone, cyclohexane, 1,2-dichloroethane, ethyl acetate, isopropyl alcohol, methanol, and methylene chloride. So on page 21, you'll see a list. And I'll show you that list right now, just so you can see what I'm talking about. Okay. So there's my list of the possible things it's going to be. And if you notice in this list, it has the density of each substance, the melting point, which we're not going to be dealing with here, the boiling point, and the solubility. The first thing we're going to do is solubility, and we're going to look at it to see if our substance is soluble in water, cyclohexane, and ethyl alcohol or ethanol. So that we'll do that first. Okay, so let's show you how I'm going to do that. It's pretty straightforward. Okay. First thing I'm going to do, in your lab report it says measure out, in the lab book it says, in the lab book here, it says measure out 3 mils. I'm not going to do that. What I'm going to do is I'm going to add about this much, okay, up to about here. I don't have to be super precise because this is what we're looking at is the intensive property. An intensive property is a property that does not depend on how much you have of it. In fact, all 3 of these experiments are intensive properties. So it doesn't matter how much I measure out because each one of them is independent of how much you do that. Okay, so first thing I'm going to do is I'm going to put in each test tubes, 1 test tube, my unknown, 2, 3. Now I keep the capped off because it's possible that this might be evaporating, so I want to make sure it doesn't evaporate. So I have my 3. I have my knowns of my. So I have my known of my and 3 samples. And what I'm going to do is in the first one, I'm going to put water. And then next one, I'm going to put cyclohexane. And the third one, I'm going to put ethyl alcohol. And let's write the results. Okay, so put water in, first one. And again, it doesn't matter how much I add. All right, let's just put them all in together first, and then we'll look at them. All right. Okay, second one, I'm going to put cyclohexane. We'll look at the results after I mix them all together here. And the third one, ethyl alcohol. All right. Okay, so let's look at each one. So this one is the water and the unknown. And I hope you can see that there is a definite separation, okay? There at the bottom, here, there's something, and here at the top, there's something. And I don't know which one it is, but I know that water and my unknown are insoluble. So write that down, that water and my unknown are insoluble. All right, my second one is the cyclohexane. Okay. And so if we look closely, see if I can get a good background here. Okay, if you can see, there's no separation. Okay, that's just a glare. Okay, so from the light from above, but it looks like the cyclohexane is completely soluble, and my unknown is completely insoluble, completely soluble in the cyclohexane. Okay, let's do the water again. I up against the backdrop here, and there you go. Okay, and you can clearly see that there's a separation between the water and my unknown. Okay, so water and my unknown are insoluble. Cyclohexane and my unknown are soluble. And then finally, the third one, okay, I just shook it up. And if you can see, it's cloudy, okay? Now, if I leave this in a second here, okay, let's see. Well, it looks like there could be a layer. You see that layer there. So it looks like it's insoluble, okay, in the ethanol or alpha alcohol. Okay, it bubbles up and it looks like they just don't mix. So our results, we're going to say that the unknown is insoluble at ethyl alcohol. So we have three results from the first experiment: insoluble in water, soluble in cyclohexane, and insoluble in ethyl alcohol. All right. Experiment number 2. Part 2 is now we're going to measure the density. And we're going to use a graduated cylinder. Let's see if we can focus in here. All right, so here's a graduated cylinder, and this is a 10 mil graduated cylinder. And so it's measured in the tenths. So if you notice, it goes 3, 3.1, 3.2, 3.4. Any graduated cylinder, any kind of graduated scale, is that you always allow one more digit than you can read, okay? So this measures to the tenths. So I'm allowed to go one more digit than I can actually read. So I'm going to record a number to the 100th. Okay, and then what we're going to do, so what I'm going to do is I'm going to add, okay, and then we have our scale, our, okay, our balance, which will weigh our liquid. Okay, so this is, there's kind of a part with this it's how we're going to measure the mass and the volume. Okay, so I have my unknown here. Okay, unknown here. And what I want to do is I want to measure the volume and I want to measure its mass, okay, for that volume. Okay, so first thing I'm going to do is I'm putting the graduated cylinder on the scale. Actually, I'm going to turn the scale on. And the scale is going to measure, it's going through its numbers now. Okay, and you can see that it says 0.02. Okay, so what I want to do is what I want to do is weigh my unknown in the graduated cylinder, but I don't want to have the graduated cylinder's mass. So what I'm going to do is put the graduated cylinder on the scale, and what I want to do is I want to get rid of the mass of the graduated cylinder, and I'm going to add my unknown to it, and then the amount of that I add to the graduated cylinder is only going to measure the mass of my liquid, not the graduated cylinder. And to do that, we have a button here called 0, which gets rid of the mass of my of the graduated cylinder. Okay, so what I'm going to do now is I'm going to take some of my unknown, okay, and I'm going to add it to the graduated cylinder, and I'm going to record its mass, and I'm going to record its volume. Okay, all right, so, and it doesn't matter how much I put in there, the graduated cylinder. Oh, by the way, this thing here is called a transfer pipette. It's plastic. They're real simple to use when you need to transfer one liquid from one place to another, and you can just throw it out when you're done. Okay, or you can keep it and use it for later on. But they're really handy. Okay, so what I need to have you do is I need to have you record this value right here, its mass, 3.63 grams. Okay, now what we have to do is measure the volume. Okay, so we're going to zoom in as close as we can get. Sorry about that. Okay. All right, there you go. So, to me, from this reading, it looks like it's 4. You can see it's just under 5, and it looks like it's 1 hash under 5. So it's going to be 4.9. And remember, you're allowed to have one more digit. And I'm going to call it, since it's almost exactly on 9, I'm going to say 4.90. Okay, so make sure you write down the 0. So it's not 4.9, it's 4.90. And you'll see that when we have the video on how to measure things. Okay, so those are the 2 experiments. And then what you have to do with this is divide the mass by its volume. Okay, so just take the 3.63 and divide it by 4.90, and you come up with a number. And that number you're gonna go to the hundreds. So your answer is gonna be some 0.71 or something like that. I don't know what it is. I don't know what your calculations will be. But that's what you have to put in your lab book or record. Okay? I will tell you what I want from this lab after we get it all done, and I'll write up and send you a report on how to do this. Okay. All right, the next thing is to do the boiling point, and what I'm going to do is I'm going to show you how we're going to set it up, and I'm going to set it up now, and show you how to set it up, and then what I'm going to do is turn this recording off, and then I have a short recording at the showing the end result of this. Okay. So let's show you what we're doing here. All right. So we're done with everything, and I'll take care of that in a little bit. But here is our setup. Okay. And so let's move this because it's kind of in the way. All right. So in the background is the hood, and so let's see, move up here closer. And excuse the moving around here, but that's how it goes. Okay, so let's show you how I set it up. Okay. Show you the components here. Okay, this is a 1,000 ml beaker, and this thing is a thermometer. A test tube, and has a glass tube connected to rubber tubing, and I'll tell you what that does in a minute. My unknown is in the test tube. All right there. Okay, and what I want to do is I want to set the test tube and the liquid, the unknown, with the unknown in the water. Now, if you take a look here, you can see that the unknown liquid and the thermometer, red bulb of the thermometer, are both under the surface. They're both submerged under the level of the water, and that's important here. Okay. There's a Bunsen burner, and I'm going to light that in a second. And then, okay, and so what we're going to do is light the Bunsen burner, and as the light the Bunsen burner, it's going to heat up the water, and the water's temperature is going to go up. The water is going to transfer its heat energy to the unknowns at the liquid, and it's going to heat up as well. And so what's going to happen is the temperature of the unknown is going to go up, and as it goes up, obviously the thermometer rises. Okay. Now if you notice at the bottom of, I don't know if you can see it, but there's some little rocks at the bottom of that of the test tube, and those are called tamer chips, and what they do is they help the boiling go smoothly. Okay. All right, so we heat it up, and what happens is the temperature of the unknown, and it'll increase, and so the thermometer's temperature will rise, and it'll keep on rising. And as it happens, what will happen is you'll see bubbles forming on the beaker. You see, eventually you'll start seeing bubbles forming inside the unknown, and it'll look like maybe it's starting to boil. What you know is boiling. Okay. Boiling is more than just getting to a certain temperature and bubbling. Okay. Actually, boiling is defined a little bit more precise than that, but that's kind of okay for here. But there is a actually better way of defining to know when something boils. So what's going to happen is the temperature is going to rise. Okay, when your unknown liquid reaches its boiling point, the temperature will stop rising. Okay, so, and that's when you know you've got to boiling. So if the temperature goes up and it stops, okay, that's when it's boiling. It doesn't matter if it's bubbling. It will be bubbling, but that bubbling doesn't determine when it boils. It's when the temperature stops going up. All right. Now, the possible temperatures that it could go up from our knowns are between 40 degrees Celsius and 85 degrees Celsius. Now, 40 degrees Celsius is about 100 degrees Fahrenheit, and 80 degrees is about 185 degrees. Right. So, so we're not gonna. So the water won't boil because water boils at 100 degrees Celsius. Make sure this fits in here. Okay. So right now the temperature says is at 24. And again, this show you. So the temperature is at about 24, and it measures into 1, so you're allowed to measure record one more digit than you can record. So I'm going to say 23.9. Okay. I guess I could write down 20.4. You don't have to record this value yet. Okay. I'm just telling you the temperature. So whatever temperature I get to, it has to be in the at the tenths. Okay. All right. So I'm going to start it up, and then turn off this video, and then I'll have the last couple minutes of the boiling for us, and I'll record that as well. Okay. So I'll show you. Show you how to start it up, because it's going to take about 15 minutes, and we don't want to just have 15 minutes of dead time on my recording here. Okay. All right, so I'll show you how to set it up. I mean, how to get it boiling. I mean, turn on the Bunsen burner. Okay, the Bunsen burner has two components. It has a gas inlet. Okay, so this is natural gas, which is methane and ethane. You'll notice that it'll be on our first test. And then the other component is air or oxygen, and that's, you'll see, and this is a combustion reaction, which will be on test number 2. So we're doing is combusting essentially methane, and methane is CH4. And so what's going to happen is the methane and the oxygen are combined in that little valve there, and we're going to light it up here, and then the methane and the oxygen are going to combine, and they're going to combust, and they're going to form carbon dioxide and water and heat. So what we have to do is got to make sure we have our air opening. Okay. Let me do that again. So have your air opening right here. Tighter. Okay. You got to have this open. If you have it closed, then nothing's going to happen, and actually it can be dangerous. So that's so your air comes in through there, and this is my gas. Okay, and that's my gas valve. So let me back up and show you how I'm going to do this. Okay, actually the best way to do this is doing it yourselves, but you're not here, so I'm going to do it for you. Okay, so notice is that I leave about 2 inches from the tip of the Bunsen burner and the gauze. This is wire gauze. Okay, this is called an iron ring. I mean, this is called a ring stand. Okay, and this piece right here that's holding it up is an iron ring. Okay, and this thing right here that holds together, that's holding the test tube, is called a clamp, test tube clamp. Okay, this rubber hosing is just in case when we get to boiling, some of the liquid will turn to gas, and if you got too much gas, he didn't have this, it actually could blow the stopper off. And so with this is sort of a release valve, safety valve. Okay, first thing I do is I turn on the gas input, and I have my gas. I have a feeling I'm going to have to, okay, I'm going to have to change this here because this valve doesn't work. Okay. Oh, yes, it does. Okay, I guess it does. Smell it. Okay. All right, I got a bad Bunsen burner. Okay. I'll have to replace my Bunsen burner. Sorry about that. Some of these things need to be better. Same idea. Okay, I turn on the source, and then what I'm going to do is I'm going to, so there's air coming in, and there you go. Okay. So what I'm going to do is I'm just let this go until it gets near boiling, and then I'll have a short video showing what happens at the end.